Okay, so we're going to move on to the next section, chapter 8. And we're going to start by talking about the, factorial function and the choose function as well. And what this will let us do is this will let us get the numbers from Pascal's triangle easily, okay, without having to do the pyramid each time. So let's talk about what the exclamation mark means. So this is called n factorial, and it's the number of ways of arranging n objects in a line. So let me give you an example. If you had a flag and you had 3 colors, what are all the possible variations that you could have? Well, you've got 3 choices for the first panel. And then you'd have 2 colors left after that. And then you'd have 1 left after that. And you actually do is you multiply these together. So it's 3 times 2 times 1. And you might remember this from GCSE maths. Okay. And 3 factorial, well, it would be 6, wouldn't it? 3 times 2 times 1 is 6. Okay. However, numbers get very, very large very, very quickly when you do this. 3 factorial is 6. 4 factorial, though, well, what is 4 factorial? It's everything from before, which is 6. And then there's a 4 at the front, isn't there? So it's 24. So the numbers will get very large very, very quickly if you do this. The choose function is what you're actually going to use directly on your calculator most of the time to get your numbers from Pascal's triangle. So we say n choose r. Okay, and I think you have to press shift on your calculator and you'll see a C, not a P, but a C. And what this is actually doing behind the scenes is it's doing this calculation that uses factorial. And if you do, for example, let's just show you, if you do something like, let's for NCR, let's do 3 choose 2. If you type that one in, check that you can do that on your calculator, you should get the answer 3. And what you're saying effectively is, how many ways can you pick 2 things out of 3 things? Okay. There's 1 way that you can pick 0 things. There's 3 ways that you can pick 1 thing. And there's 3 ways that you can pick 2 things. And we'll see this a little bit later. But what 3C2 is doing is it's picking this number here out of Pascal's triangle. This is the calculation that it's doing, by the way. It's doing 3 factorial, because our n is 3. So it's doing 3 factorial over r. Well, we said our r was going to be 2 here. N minus r, 3 minus 2, that's 1 factorial. Okay? And what that's really doing is that's the same as 3 times 2 times 1. 2 factorial is just 2 times 1. And 1 factorial is just 1. This is why you're getting the answer 3. Okay, so this is called the choose function here, and it lets you pick this out. I will explain exactly how I knew that 3 choose 2 gave me this number here in a moment. But if we do this, we can get the number from Pascal's triangle, and we can do a binomial expansion much, much, much faster. The intuition behind this formula, I'm not going to talk too much about, but if you remember from your statistics before, if you remember, say you had the word statistics, and you were asked questions about like how many ways can you arrange them, you might remember that when you had 2 of the same letter, it didn't matter. So you divided by 2 and so on. That's a little bit of the intuition, perhaps, where this is coming from. Here's an example. If you are a football team captain and you need to choose 4 people from 10, so the bigger number is always your n, okay? So that would be your n, 4 would be your r. There are 10 choose 4, and it's sometimes written like this, 10 choose 4 ways that you could do it. 10 factorial divided by 4 factorial times 6 factorial, you'll get a very large number, okay? So calculate the following. You may use factorial, but you're not allowed to use the NCR button for this one. So we're going to use n factorial over r factorial, and then n minus r factorial there. So 5 factorial, remember, is just the same as 5 times 4 times 3 times 2 times 1. You might remember we just said that 4 factorial a moment ago was 24. So this will be 5 times 24. Okay, 5 choose 3. Well, if we put this one in, we'll get 10. And notice how, this is a lot more preferable to me doing this, because I don't even actually have the space really for that 5th row. 1, 5, 10, 5, sorry, 1, 5, 10, 10, 5, 1. 5 choose 3, 0, 1, 2, 3. So that's the number that I picked out there. 0 factorial, you'll be quite surprised by the result here. It's 1. Just accept this for now. You're going to see why it must be 1 in just a second. 20 choose 1. Do you remember the pattern from the pyramid that said the second part here, okay, always gave you the row number? So that's actually 20. If you put it in here, 20 factorial over, well, what is 20 factorial? It's 20 times 19 times 18, dot, 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 dot. 1 factorial is 1, 19 factorial is 19 times 18. So you can see things are cancelling out. You can see why you're getting that number there. E, let's look at 20 choose 0. You know the answer is going to be 1 because the first number is always 1. Why must it be 1? Well, 20 choose 1 means how many ways are there of picking 0 things out of 20? Well, there's only one way, which is that you don't pick anything at all. That's why the answer is 1. When we substitute it into the formula, we get 20 times 19 times 18 at the top. We have a 0 factorial there, and then we also have 20 times 19 times 18, etc. So these bits here sort of cancel. So you have a 1 in the numerator. 0 factorial needs to be 1 for this to work. Otherwise, it doesn't make sense. 20 choose 2. Look how they've written it out this time. 20 times 19 times 18. So 19 you cannot cancel, but you would cancel all of this here. So you get 20 times 19 divided by 2 factorial. Okay? This here, you will see this again in year 2, whereas in year 1, you pretty much use the calculators to do it. You don't deal so much with behind the scenes except for harder questions. 20 choose 18. Well, 20 choose 18 compare with the denominator for 20 choose 2. And it's really the same thing. If r is 2, n minus r will be 18. If r is 18, 20 minus 18 will be 2. So this explains why Pascal's triangle is symmetrical. So why is it useful? Well, now we know that these numbers can be generated from this. Notice as well that we have positions, we're going to see on here, we have positions of choose 0, choose 1, choose 0, choose 1, choose 2, choose 0, choose 1, choose 2, choose 3. So you always have how many terms? One more than the row number. Okay. So why is it useful? Well, it's very useful, for example, if we wanted to expand out this bracket here. And, we saw this before. X plus 3 to the power 20. I don't have to do my triangle. I can just put in 20 choose 0, 20 choose 1, 20 choose 2, and so on and so on and so on. And why does it work? Well, the reason why it works, let's use an easier example. When you did a plus b squared, you were saying that this is a squared plus an ab, then also plus a BA the other way around, weren't you? But we put this together as 2AB. So the reason why this is all linked, the choosing and the algebra and so on, is because this covers all the different ways that things can happen. Consider a plus b to the power of 5. how many A cubed B's are there? Well, how many ways of choosing 3 A's are there? You could pick an A and an A and an A, and then a B and a B. You could pick an A and a B, and then an A and a B and an A, etc. This is an awful lot of work, okay? But really what we're doing is we're saying, how many ways can you choose 3 of the A's from the bracket out of the 5? Okay, that's why this all works. So we've covered this now. Let's go back and actually do a question. This is the formal way of writing the binomial expansion. It looks very, very difficult, but all it's really saying is you have the first term with all of the power, and the other term has none of the power. Then what we do is we have Pascal's numbers. Well, don't forget, really, there is an n0, but n0 is always 1. And the power goes down and down, and the power on the B goes up and up and up. So this is going to be exactly the same as the previous lesson. I'm just going to say that we can now use n choose r to get these numbers quickly. So the first 4 terms, well, I know the first one's always 1 anyway, so I can just do that. 10 choose 1 is going to be 10. You don't even really need a calculator for that part there. I will need a calculator, though, for the other parts here. Okay, and as before, I have my 2 different pieces, and I write them in ascending powers of x. Okay, so 3x and 1, 3x and 1. It said the first 4 terms, 3x and 1, 3x and 1. In ascending powers. So I tell you, I'm going to give all of the 0 to the x to start with, and then I'm going to build up. And then what will this be? Well, this will be 10, because it needs to add up to the power. So 1 plus what is 10? 9, 8, 7. Okay, this is all that you need to do. Lots of this will cancel out, notice. 1 to the power of 10 is 1. 1 to the power of 9 is 1. 1 to the power of 8 is 1. 1 to the power of 7 is 1. 3x to the power of 0 is 1. So the first thing is going to be 1. Plus 30x. These numbers, okay, I put a ... there before. I need to get these numbers now from my calculator. So as I don't have one directly in front of me, I'm going to reveal it and we're going to talk through. So 1 choose 0, remember, is just 1. 10 choose 0 is just 1. 10 choose 1 is just 10. So we looked at how we were able to get these without a calculator. 10 choose 2, I cannot do off the top of my head. Okay, I'm not sure, unless perhaps I use the factorial notation. I suppose we could do it like this, couldn't we? Okay, but you would just chuck that in your calculator. We only need to go up to x cubed because this is the first term, second term, third, fourth, and it only wanted the first 4 in ascending powers of x. Power of 0 is a power of x. Okay, so same as before, we're just using our calculator rather than Pascal's triangle. Pause the video, have a go at this one here, and my hint to you is that 2 is going to be your first piece, and then minus a third x is going to be the other. Careful with making sure that you fully apply the power to all parts for the second piece here. Pause the video, have a quick go. Okay, so I'm going to assume you've done that. Let's have a look. We only need the first 3 terms in ascending powers. So in other words, give all the power to the non-x bit to start with and go down. Then apply 1 power and then 2, and that's it. Okay. We're going to use calculator to get this one here. You could use calculator for all of them, but you know that's 1 already, and you know that that will be 7. And just careful with this one here. You're going to get a 9th. Okay. They've done some simplifying and worked things out ahead. And then they've actually, interestingly, they put the sorry, they put the x and then sort of the x squared afterwards. They're just really looking at the coefficients there and slotting them in front of the x and x squared. Time for you to have a go.